Hello, precious one. I welcome you once again to Kenyako, my concept classroom. Today we are going to look at the continuation of sequence and series. But on this particular episode, we'll be looking at the geometric progression. We are going to look at the second type of sequence, geometric progression. We call this the GP or the exponential sequence. Exponential sequence. Now, we are done with the linear sequence or the arithmetic progression. And so I will advise that if you are watching me for the first time, you go and find my videos on the linear sequence or the arithmetic progression. But on this particular episode, we are going to look at the geometric progression or the exponential sequence. Now, with the exponential sequence, a sequence is said to be an exponential sequence if it has the same common ratio. Don't forget that when we were looking at the linear sequence or the arithmetic progression, we said that a sequence is said to be a linear sequence if it has the same common difference. By here, a sequence is said to be a geometric progression or an exponential sequence if only it has the same common ratio. So with the linear sequence, it's common difference. With the exponential sequence, it's common ratio. So now, let's assume that we have the sequence A, B, C, D. And this is an exponential sequence. The first term is A, the second term is B, the third term is C, and the fourth term is D. So now, if you want to find the common ratio, this is how we find the common ratio. Now, the common ratio, R will be B over A. That's the second element divided by the first element, or the third by the second, that is C over B, or the fourth by the third, that is B over C. So that is how we find the common ratio of an exponential sequence. Now, let's take a look at the question. Let's take a look at the question and see how best we can explain that. Let's assume that we have the sequence 2, 4, 8, 16 in that order. When we look at this sequence, this is an exponential sequence because it has the same common ratio. Now I'm going to explain that. When you look at this can't be a linear sequence. The reason is that the difference between 2 and 4 is 2, but the difference between 4 and 8 is 4, and the difference between 8 and 16 is 8. So you realize that it doesn't have the same common difference, but we are going to look at the common ratio. Take note that the first term is 2, and the common ratio is 4 divided by 2, or 8 divided by 4, or 16 divided by 8. Realize that you are getting 2. So this sequence is an exponential sequence or a geometric progression because it has the same common ratio. It has the same common ratio. Now, let's look at the nth term. The nth term of a GP. When I say GP, then I'm talking about the geometric progression or the exponential sequence. The nth term is given by UN equals AR exponent n minus 1. Don't forget that the A is the first term of the sequence. That is the first term of the sequence. R is the common ratio. R is the common ratio. And N is the number of terms. Is the number of terms. So this is the nth term of an arithmetic of a geometric progression or the exponential sequence. This is the formula for finding the nth term of a geometric progression or the exponential sequence. A is the first term, R is the common ratio, and N is the number of terms. The number of terms. Now, let's consider an example. Let's assume that we are asked to find the system of the sequence. Find the system of the sequence. You have 2, 4, you have 8, you have 16 in that order. Now, this is the question we are given. We are asked to find the system. So our n is equal to 6. N is equal to 6. Now let's write the sequence. The sequence is 2, 4, 8, 16. And now we know that the first term, you can see that the first term is 2. Then our n, from the question, find the sixth term. That is the n. So n is equal to 6. And we need to find the common ratio. The common ratio is r. That is 4 divided by 2. And the result is 2. Or you can divide 8 by 4. You still get 2. Or 16 by 8. You still get 2. So this sequence is an exponential sequence because it has the same common ratio. Don't forget, it has the same common ratio, not common difference. Okay, so we have to find the system. We have to find the system. Now we know that the formula is un equals ar exponent n minus 1. Now a is 2, n is 6, and r is now 2. So by substitution, we have u6 equals a, that is the first term, 2. R is the common ratio. Common ratio is 2, and n is 6. So 6 minus 1. And this should be 2, and we have 2 exponent 5. Don't multiply 2 by 2 before you raise it to power 5. Rather, we have 2 raised to the power 5, and that is 32. So we have 32 times 2, and this will give you 64. And this will give you 64. So that is how we find the sixth term of this exponential sequence. So that's the application of the formula. So it's un equals ar exponent n minus 1. Exponent n minus 1. Now let's assume that we have to find the seventh term. Assuming that we are finding the seventh term. If you are finding the seventh term, it means that your n will be equal to 7. But the a, that's the first term, will still be your 2. Common ratio will still be 2. And so if you have to find the seventh term, it will use 7. Then a, and a is 2. R is the common ratio, that is 2. But the n is now 7, so it will be 7 minus 1. And this will be 2 times 2 exponent. 7 minus 1 is 6. So 2 raised to the power 6 will give you 64. And 64 times 2 will give you 128. 128. And so this will be the seventh term of this exponential sequence. So you can also find the eighth term, the ninth term in that order. So that is how we apply the formula un equals ar exponent n minus 1. So don't forget that we are saying that a sequence is said to be an exponential sequence if it has the same common ratio. A sequence is said to be an exponential sequence if it has the same common ratio. I will advise that you reverse the video, you take the video back, you watch it, get your book, get your pen, get your calculator so that you can follow what I am doing. Because mathematics is practical. And so now, that is how we find the nth term. That is how we find the nth term of a linear, of an exponential sequence. That's how we find the nth term of an exponential sequence. That's how we find the nth term of an exponential sequence, or GP. That is geometric progression. Now, let's look at the sum of a GP. We are looking at how to find the sum of a GP. And the formula is given by Fn. We have a 1 minus r exponent n over 1 minus r. And take note that r should not be equal to 1. Why are we saying that? If the common ratio is 1, 1 minus 1 is 0. Whatever we have at the top divided by 0, you will not be able to find the sum of that number of terms or the sum of that exponential sequence. So we have a into bracket 1 minus r exponent n, all divided by 1 minus r. The a is the first term, the r is the common ratio, and the n is the number of terms. Now take note of this. This is, we have Fn, we have a 1 minus r exponent n over 1 minus r. When the common ratio is less than 1, it's appropriate to use this formula. Take note of that. Now Fn equals a, we have r exponent n minus 1 over r minus 1. This, when r is also greater than 1, it's appropriate to use this. But you get the same thing. It's appropriate to also use this. So take note of that. So your common ratio should tell you which of the formulas you're supposed to use. which of the formulas you are supposed to use. But in all these cases, remember that your r should not be equal to 1. Your r should not be equal to 1, because if the r is equal to 1, the denominator will go to 0, because r minus 1 will be 1 minus 1, that will be 0. Everything we have divided by 0, we will not be able to find the sum. And therefore, if the common ratio is less than 1, then you use this formula. If the common ratio is greater than 1, then you use this formula. So in general, this is the formula for finding the sum. That's the formula for finding the sum of an exponential sequence, or a GP. Now we are going to take a question and see how best we can use the formula to solve such problem. How you can use the formula to solve such problem. Now, let's assume that we are given the sequence is 2, we have 4, we have 8, we have 16, in that order. And we have to find the sum of the first 5 terms, the sum of the first 5 terms of this particular sequence. Now take note, in solving this problem, the sequence is 2, 4, 8, 16. So you can see that this is an exponential sequence because it has the same common ratio. 4 divided by 2, 2. 8 divided by 4, 2. 16 divided by 8, 2. So it has the same common ratio. Now you can see that a equals 2. That's the first term. Common ratio is 4 over 2, and this is equal to 2. We have to find the sum of the first 5 terms. The sum of the first 5 terms. That means that n is equal to 5. So the formula S. Take note that the common ratio is 2. That is greater than 1. So we have S n equals a, and we have r exponent n minus 1, all divided by r minus 1. So you can refer, and you know the reason why we are using this formula. So Fn equals a, that's the first term, is 2. Then you have r, and the r is 2, exponent n, and n is 5, so you have 5 minus 1, all divided by r minus 1. R is 2, so we have 2 minus 1. To simplify, this is 2 exponent 5 is 32 minus 1, all divided by 2 minus 1 will give us 1. So Fn, don't forget that the n is 5. So S5 will be equal to 2 into brackets, and we have 32 minus 1 will give us 31. And all divided by 1 is the same thing. So 2 times 31 will give us 62. Will give us 62. So that is the sum of the first 5 terms of that particular sequence. And so that's how we apply the formula. That is all. That's how we apply the formula. So take note of that. Take note of that. Now, let's assume that you have to use the other formula. You can try that and see, because I'm saying that mathematics is practical. So use the Sn equals a into bracket 1 minus r exponent n divided by 1 minus r, rather, and see the answer you are getting, so you understand what you are talking about. So the sum of the first 5 terms is equal to 62. This one means that because you can see that if you have the first term and you want the second term, instead of adding in terms of linear sequence, you rather multiply by the common ratio to get the next term. So the common ratio is 2. So 2 times 2 will give you 4. 4 times 2 will give you 8. 8 times 2 will give you 16. 16 times 2 will give you 32. So you have 32 here. If you want to get the next term, you multiply 32 by 2. That will give you 64 times 2, 128, in that order. So we have to find the sum of the first 5 terms. 1, 2, 3, 4, 5. When you add all these terms together, you should get this. You can try that and see. And that's the application of the formula. And that is really what is happening. So in general, that is how we find the sum of an exponential sequence. You'll be solving a lot of questions so you understand how to really apply the formulas. But that will be all for now on this particular episode. Bye-bye for now.